Video problem 75, using equilibrium constants. So let's take a look at what we have. A 1 liter flask is filled with 1 mole of hydrogen and 2 moles of iodine. Let me talk about that real quick. Remember, in your equilibrium, it's concentrations, right? So luckily, in this case, we can say 1 mole of hydrogen is in 1 liter, so we can calculate our molarity easily. It's 1 mole divided by 1 liter. If this were a 2 liter flask instead, then I would divide by 2 and my molarity of hydrogen would be 0.5 molar. Okay, but it's not. But I just want to mention that real quick. Alright, so I have a 1 liter flask. It's filled with 1 mole of hydrogen and 2 moles of iodine. That's it. The value of the equilibrium constant is 50.5. And I want to know what are the equilibrium concentrations of these three things. So all I know is initial concentrations. Let's set up the equilibrium expression first. So it's going to be Hi squared over hydrogen times iodine. Right? I don't know any of these three. Got to use an ICE table. So I do know that this is equal to 50.5. Let's fill that out. So let's use the ICE table here. Okay, remember these are all concentrations in here. Alright, so the initial concentration of Hi is 0. Iodine, it's 2 molar, and hydrogen, it's 1 molar. Oh, for some reason I wrote a T. Hydrogen, it's 1 molar. Okay, now we're only starting out with the reactants. That means the reactants have to go down when they change. So it's going to go down by some amount x, go down by some amount x. That means Hi is going to go up because it's a product. It's going to go up by some amount 2x. So now I don't know any equilibrium concentrations. So this is 2x, this is 2 minus x, this is 1 minus x. So I can plug these back in. All these x's are the same. So I'm going to plug these values back into my Kc. So Hi is 2x squared. Hydrogen is 1 minus x. And iodine is 2 minus x. And you may see where this is going. We are headed toward a quadratic formula. Okay, so let's get to that point. I'm going to FOIL this. Right. So once I FOIL that, I end up with something that looks like this. I get 4x squared up top, because that's 2x squared. Then on bottom, I'm going to get 2 minus 3x plus x squared. Okay, and again I just FOILed it. Now that whole thing is equal to 50.5. I'm going to multiply both sides by 2 minus 3x plus x squared. So I end up with something that looks like this. 4x squared is equal to 101 minus 151.5x plus 50.5x squared. Now I need to set this equal to 0, so I'm going to subtract 4x squared from both sides. So now 0 is equal to 101 minus 151.5x plus 46.5 x squared. Now I have A, B, and C, so I can plug this into the quadratic formula. So here's the quadratic formula. It's x is equal to plus or minus, or no, pardon me, x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. So I'm going to get two answers here, right? So let's plug everything in. X is equal to 151.5 because it's negative, so that becomes positive, plus or minus the square root of 51.5 squared minus 4 times 46.5 times 101 all over 2 times 46.5. So, work through that. You end up with two answers. You end up with x equal to 2.32 or x equal to 0.930. So we need to figure out which of these two values is the correct value, and it's pretty easy to do. Let's take, make this a little smaller here. Let's take this 2.32 first, okay? And we're going to plug it into here. Well, obviously, when you do that, you get a negative molarity. You can't have a negative molarity. So that cannot be the answer. So hopefully, this is the answer, 0.930. So if I plug 0.930 into my value here, I'll get a positive value, positive value, positive value. So my x ends up being 0.930. So now I can plug that back in to my equilibrium expressions right here, my equilibrium values, and I can get the actual equilibrium. So this is going to be 2 times 0.930 is equal to the equilibrium concentration of HI. This is going to be 2 minus 0.930. That'll be the equilibrium concentration of iodine. This is going to be 1 minus 0.930, which is the equilibrium concentration of hydrogen. Okay. So just to give you those actual values, I think I have it up here. Yep. So this is going to end up equaling 1.86 molar. This is going to end up equaling, what is that? 2 minus 0.930, 1.07 molar. And this is going to end up equaling 0.07 molar. Okay, so there's an example where we have to use the quadratic formula because we end up with a quadratic equation.